Division is a concept that lots of students find really challenging. And if, like me, you learned how to divide years ago, 20-some years ago in school, you might find that you're confused by division these days too. So what I want to do today is show you the different ways that you can divide, the way that we learned in school and how that connects to the way that we teach our students how to divide now. So when we were in school, if we had a question like this, 168 divided by 8, we would start by using long division. And we would start by thinking, okay, how many times does 8 go into 1? 8 doesn't go into 1, but 8 does go into 16 2 times. When you put 8 into 16 2 times, that's 2 times 8, which gives you 16, and you don't have any left over. Now you need to bring down the 8. Some people use that arrow, some people don't. You put the 8 there. How many times does 8 go into 8? 8 goes into 8 one time, and you have none left over. The benefit of the long division strategy is that it's very efficient and elegant. But if you're just learning it for the first time, it's very confusing and it's a step too far. The long division algorithm focuses on steps within an algorithm as opposed to understanding of what the numbers mean. So the way that we teach the partial quotients method in school is the way that we teach division in school is by using a method called partial quotients. Now the answer in a division question is called quotient. And so what we're doing is we're finding the quotient bit by bit. In a way, long division is a partial quotient method. But in the partial quotients method that we teach at school, you find it part by part in a slightly different way. The setup looks a little bit different too. Instead of doing the curved bracket with the straight stick, we might set it up like this. We would start the same way, except instead of focusing on how many times does 8 go into 1 and how many times does 8 go into 6, we're actually going to look at this as a whole big number. We could start by thinking, well, how many groups of 8 can I put into 160? How many groups of 8 go in there? But when we're just thinking about numbers in a really sort of abstract way, it can be really difficult for students to conceptualize. So we like to start with contexts that are really real to them. One of the contexts we've used a lot in class is the context of the vending machine. So in this problem, we would say, okay, I've got a vending machine and it's going to hold 168 candy bars, and there are 8 different kinds of candy bars that I need to put in. How many of each kind of candy bar could I put into this vending machine? Could I put 10 of each different kind of candy into this vending machine? Well, yes, I could. I could put in 10 and I could put in even more. So I could say here, I'm going to put in 10 of each kind. And I've been really prompting the kids to put down what does this 10 mean. So I could have them right here, 10 of each kind. If I put in 10 of each kind, it means that I've put 80 candy bars into my candy machine or my vending machine. And now I need to figure out how many spaces do I have left. Well, 168 minus the 80 that I just put in gives me 88 spaces left. Could I put in 10 more of each kind of candy bar? Well, yes, I could. I could still put in 10 more of each kind of candy bar. That would be a total of 80 again. And I would have 8 spaces left in my vending machine. That would allow me to put in 1 more of each kind for a total of 10, 21 of each kind of chocolate bar or candy bar. Now, this method of partial quotients actually allows for a lot of flexibility. I would consider this to be more of a beginning partial quotients attempt. Of course, what we're hoping for is that students would get to the point where they actually take this problem and do it quite a bit more similarly to the way we would have done long division. So what they would do instead is I've used up a lot of my space here, so let me do it here, just a little bit smaller. So we've got 8, 168. Well, I can put in 10 of each kind of candy bar into this vending machine, but actually I could put in even more than that because I know that 8 times 2 is 16, so 8 times 20 is 160. I could put in 20 of each kind. And that means that I have 8 spaces left in my vending machine. I know that that's 1 more of each kind, and I have none left. 1 of each kind. This is where we would expect fourth graders or want fourth graders to get in fourth grade. And most of them get there, but lots of them start here, especially if they don't have strong mastery of their basic facts, which is another reason why we continue to promote the use of reflex math. I'll show you one more time with another question. 152 divided by 8. This one's a little less easy to see. Now, the students who are really on the ball are going to see that 152 is just one group less than 160, one group of 8 less than 160. So they should be able to tell you right away that it's actually 19. But if they haven't noticed that, then we could start the way that we did over here, because we can't fit 20 of each flavor of chocolate bar into our vending machine, but we could fit 10 of each flavor into our vending machine. And then we have 72 left over. Students who have strong mastery of their basic facts will know that 72 divided by 8 is 9. I could put in 9 more of each kind, and I end up with none left over for a total of 19. This procedure of partial quotients, I hope, made sense to you intuitively, and it does definitely make more sense to our students in fourth grade. Please let me know if you have any questions. I'm always happy to help.